Hi, my name is Alyona Medelyan, and I lead the research at a New Zealand company called Pingar. And today I'm presenting joint work that we did with Anna Divoli. She was a postdoc at the University of Chicago. I actually found Anna's screenshot of one of Anna's work in Marty's book and contacted her because it looks so similar to something that we developed at Pingar, and I wanted to evaluate it. But I've never run a user study before. So I suggested we collaborate, and luckily Anna said yes, and these are the results of our research. We decided to study the features of a search user interface and how useful they are. And we focused on bioscience because this is one of the verticals of interest to Pingar and Anna's background as well. We have identified 5 features that were of interest. And here they are in a very typical system that is used for searching biomedical data, PubMed. One is autocomplete, and you guys are all familiar with this. Search expansions are ways of modifying the search query to find more results. We also looked at facets, and PubMed suggests the facet of refining search results based on their type, but there may be many other ways of using facets as well. Related searches help to refocus the search, and results preview shows, in this case, what is the title of the document, who are the authors, what's the journal, and yeah, it depends. We added a second dimension to our research by looking at the search tasks similar to Leanne. In a paper by Keller, they found that majority of the tasks are related to transactions, such as writing emails, doing online banking. And the remaining tasks are spread evenly between fact-finding, information gathering, and browsing. We actually found that in bioscience, it's pretty hard to identify the task, the type of the search tasks. But looking at these actual descriptions of search results by our participants, you can see that there is some similarity. So animal models of Huntington disease is quite specific, so we call it a fact-finding search task. If a researcher wants to find information on that relates to their own studies, it's information gathering. And if they're just browsing a new publication in a given area, then it's browsing. So our research questions were, how useful are the 5 features of a search user interface for searching in biomedical text, and how that, and we hypothesized that it depends on the search task. And in addition, we also wanted to find out what works best in terms of representing and computing facets. Our hypothesis was that it's better to display dynamically computed facets rather than a complete list of everything that's available in a facet hierarchy. We first ran an exploratory study where we emailed, we interviewed and questioned several bioscientists and just asked them in general, explain them the search tasks, and asked for typical queries that they would categorize under those types. We then used the results from the study to design our main study with 10 bioscientists. They were all experienced researchers, and they were very keen to participate because it's crazy to their current. Wait, what's happening?
I'm working on it.
We emailed the participants in advance and asked them to provide us search queries.
Anybody have one of those iPhones?
And so we used the responses by the participants, the actual search queries that they use in their work, to create screenshots of how various systems implement specific interface features. So here we use the PowerPoint presentation to compile them all in one place and show it to participants. And here's this presentation for one of our baseline queries, ConnectSyn. Can anybody recognize where is Google and where is Bing here and where's PubMed? I can. So we didn't tell the participants which system is which, but you can see that how different systems treat such a common feature as autocomplete. We also had a commercial system, Go PubMed, and NextBio, another commercial system, and a research prototype, Semedico. So not all systems implemented all of the features. For search expansions, we had an internal implementation using Pingar technology, which is presenting a checkbox, and if the user selects it, we build a Boolean query. And PubMed, you already seen this example, has quite a specialized search expansion option. For faceted refinement, we tested several systems developed by Pingar using our API. And we also used Solar to generate facets based on existing metadata assigned to medical articles. At the bottom, you see the PubMed facets, and E is a system with a full hierarchy of terms from a research prototype. We also tested the same presentation, but with checkboxes, and Go PubMed used checkboxes for their facets as well. We also looked at related search queries, and you can see how different the suggestions are that users would get if they use those systems. So we were focused specifically on the content, but also collected users' ratings on design. In terms of the search results, we have compared only two systems, both developed at Pingar, and one is using standard tools available through the Solar search engine, which is C. We compared keywords that were driven from the metadata assigned to the articles with those that we automatically identified using our keyword extraction tool. And for previewing the actual content of the document, we compared snippets calculated by Solar with a text summarization tool by Pingar, where you mouse over and the context of that sentence is displayed. We have collected a lot of data and put it all into a single spreadsheet, and I would really welcome those tools that make user studies less of a hard work. So in the first column, we compiled all the information we knew about each participant, and all the remaining lines represent ratings of various features. So you don't have to read this, but this is a rating of one participant and how they evaluate the autocomplete for the query animal models of Huntington disease. We asked them on the Likert scale how useful they would consider this feature when searching. And below, we have collected scores for individual systems separately for looks and for the content. And we also ask them to rank the system in order of their preference. We then ended up compiling the results to support our research questions. And the first research question was, how useful are different interface features? So, and whether it depends on a search task. So here we have a stroke representing a single participant, and green denotes the positive ranking of a feature. And if we look at autocomplete, at the very top, you can see that 3 people were performing a browsing task, and they all said that autocomplete is useful as a search feature. People who were performing fact-finding disagreed, and people who were information gathering were predominantly neutral with respect to autocomplete. Regarding query expansion, somewhat more positive responses on browsing, but very mixed opinions for the other search tasks. Whereas faceted refinement has been rated highly for all the features equally. Related searches, on the other hand, was negatively ranked, and this is participant commented on this. They rarely use the related searches option because they know what they're looking for and they don't want to change the focus of their search. They're more interested in refining, and this is where facets are very useful. And the preview of search results is useful. It's kind of intuitive. You have to know what results are returned. So participants commented why they found autocomplete is less important. They say they feel pigeonholed by those suggestions, so they don't want to see them. And with regards to facets, they commented that they should be focused on their search queries. So if they're looking for a particular disease, they would like to see the symptoms, and they really like the category organisms. So, but when they saw one of the systems that had a very large number of facets, they felt overwhelmed, and we had to force them to actually look at the system because of how many colors were used there. So checkboxes is something where they all said are very useful. They want to select multiple choices. And in terms of how these findings relate to previous research, our findings are in agreement with autocomplete, but with regard to facets, other research have found that participants do like a full hierarchy, not bioscientists, though. So in general, our participants told us that the looks of our system has to be good enough for them to use it, but what really matters is the relevance of the suggestions. And yeah, so I think this is an important finding. So to conclude this talk, we asked whether search interface features are useful for various search tasks in biomedical literature, and we found that facets and results preview are useful, whereas other features are more useful for browsing. So if you're designing a search interface, do not waste your time coming up with a great algorithm for related queries. In terms of faceted navigation, very few query-oriented and specific values is something that bioscientists prefer, and they like to use checkboxes. Another finding is that Anna actually now not at University of Chicago anymore. She's in Greece and applying for a visa to come to New Zealand. So I'm looking forward to more experiments with her.